What's up, guys? Mr. Rushka here. My apologies for, muffing example 6 today in class, and it was just really on my mind all day, and I just thought, I gotta make a video, gotta treat that problem with the dignity and respect it deserves, right? Okay, so here it is, right? Particle moves along the x-axis with this position function, all right here, right? So this function gives the position of the particle along the x-axis as a function of time, t, okay? So if we think about, the x and y axes, right, this function x describes the position of the particle along the x-axis, okay, as time goes by, okay? So they want us to determine, right, they give us these 5 values for t. T is the variable we plug into our equation, into our function for x. They give us these 5 values for t, and they ask us, okay, for which of these 5 values of t is the particle both to the right of the y-axis and speeding up, okay? So what does it mean mathematically? For the particle to be to the right of the y-axis? What does that mean? Right, so to the right of the y-axis, so this area here, let's highlight that, right? All the area to the right of the y-axis means x of t, right? Our function there, our function x of t is greater than 0, okay? So for one of these values of t to fit our conditions, it has to be the case that when we plug that value of t into our function x of t, that x is greater than 0, okay? That has to be the case, all right? That has to be the case. Cool. Right. Then there's one other conditioning, speeding up. So what does that mean? Well, it means that that particular value of t, v of t, and a of t, the acceleration and the velocity, have the same sign, right? They have to have the same sign, okay? So we have x of t, right? We can plug each value for t into x of t, right? So let's go ahead and do that. Okay? So we have t equals 1, 2, 3, 4, and 5, okay? All right, and then we're going to have x of t for each particle, okay? So let's do that with our calculator here. Okay. All right. Second, okay, here's how we're going to do this. All right, so we have our function x of t sine e to the 0.5 t, okay? All right, we do the same method we did in class. All right, let's do this, okay? All right, so my problem was the function they gave me was sine e to the 0.5 t. Sine e to the 0.5 t is what they gave me, okay? Put that in here, okay? So it's going to be sine second, where's e to the 0.5 t. In this case x, then right parenthesis, okay? So let's go ahead and graph that, okay? So make sure you write, if I notice that this equal sign for the y1 equation is like kind of like highlighted in black, make sure that's, if that's not highlighted like that, here's what's going to happen, it's not going to graph anything. So go to y equals, okay, hover the cursor over the equal sign, hit enter, okay? Now hit graph. All right, cool, sweet. So that's our position function, okay? Now, we have these 5 values of t, right, to plug into our equation, and we want to plug all of those into that x of t graph we just made on our calculator, and then see if that value, that y value that gets popped out is either positive or negative, okay? One thing I want to note, I think some people might have had trouble with this, okay? If you go to mode, let's hit mode on my calculator, it needs to be in radian mode, okay? There's a sign, anytime I have like a sine or a cosine or an inverse trig in my graphing calculator, I need to make sure that the mode is set to radians unless otherwise specified, okay? Alright, so let's go to our graph here, alright? Now the way we plug, let's plug t equals 1 into our graph. The way you plug a number into your function here, that y1 function in the top left, is you have the graph pulled up, you hit trace, right? Then you hit 1, right? Then you hit enter, okay? It'll spit out your y value. Look, the y is 0.9969, okay? That number is greater than 0, guys, okay? So that's positive. So that's positive. So we got a positive, not positive sign for t equals 1, okay? Let's do the same thing for t equals 2. T equals 2. Okay. 2. For 2, it's positive, right? We use the trace button, right? We use the trace button, typed in 2, hit enter, gave us a positive number out, okay? Let's do the same thing for 3. That gives us a negative, so it's positive for t equals 2, negative for t equals 3. Negative for t equals 3. All right, sweet. Sweet O. Sweet O. Okay. Let's plug in t equals 4, so we hit trace, 4, enter. All right, positive number pops out. That number is greater than 0, okay? Trace, 5, enter. Negative number, okay? So for t equals 4, we have positive x of t, and for t equals 5, we have a negative x of t, okay? Now, so that's that first condition, right? So for any of these 5 values of t to be part of our answer, for us to say yes, it's to the right of the y-axis, right? We've got to have x of t greater than 0, okay? That's not the case for 3 and 5, so we can just cross those out. Don't even have to worry about them anymore, okay? Now we have to check what? We have to check our condition here. We have to make sure that v of t and a of t have the same sign. So we need to take 1, t equals 1, t equals 2, and t equals 4 and plug them into both my velocity and acceleration equations, okay? We don't actually have those now, do we? Like the problem doesn't give them to us. How do we find them? By taking the derivative of x of t, right? v of t equals x prime of t, which in this case, all right, we actually don't have to do it by hand, right? We can do it on our calculator, okay? We can just graph that on our calculator, and then plug the values in on our graphing calculator app, okay? Bring it focus on my iPad camera, okay? So here's what we're gonna do, okay? So we have my function y1 here, okay? y1, right? Hit the down arrow, okay? And we want y2, our red graph, right? We want it to graph that red graph. We want that to be the first derivative of that y1 function. That y1 function is our x of t, our position function. We want the derivative of that because we want our velocity function. So we're going to hit math. Scroll down here and hit nderiv. There you go. Okay. So to graph the first derivative, you're going to put an x there, d over dx. Okay. You want to take d dx of y1, so hit the vars key. Hit the vars key. Hit the right arrow key. Go to y vars. Hit enter on the function menu. And hit y1. There you go. There you go. And then to graph this whole thing, you just do x equals x. Okay. Cool. Now, what we want to do here, right, we only want to see the velocity function. We want to plug our t's into the velocity function, not the position function, okay? So notice these these equal signs here, okay? They're both highlighted in black. That means our calculator is going to graph both of them for us. We only want our calculator to graph our velocity function, okay? So we're going to go ahead and unhighlight that equal sign for the position function and only highlight the velocity function. Okay, so let's graph that. Alright, it might take a little bit because the calculator has to work really hard to calculate all those derivative values, okay? Here we go. Okay, now what we can do is we can go ahead and just plug in all of our t values here into v of t. Okay? Let's go ahead and do that. Okay? So we make double check, we've got our velocity function graph here, this red graph. Let's plug in t equals 1 to it, so we're going to hit the trace button. We're going to tell our calculator, hey, plug 1 into that y2 equation, okay? Hit enter, that gives me a negative. Okay? Let's plug in 2, so t trace 2, enter. Woo-hoo. I just hit enter one too many times on accident, so we have to wait for it to regraph. Oh, yeah. Okay, we go. So trace, yep, x equals 2, and then t equals 2, that number that we plugged into our velocity equation, we got a negative number, okay? So we had a positive, then we had a negative. We had a positive, and then a negative. Okay? Let's do, now we just have to do 4, right? We're going to have to worry about 3 and 5, because they didn't satisfy our first condition, right? Let's do 4 now, okay? Oh gosh. Oops. Alright. Actually, what I'm thinking, did I put the right thing for v of t? For t equals 1? Okay, let me make sure. Okay, when t equals 1, it was negative, right? This is my velocity function. When t was 2, it was also negative. Okay, so I wrote down the wrong thing here, guys. I'm sorry. Just a little mistake. It should be negative. Negative, okay? And then 4, t, we're going to plug in t equals 4. That's it. Trace 4, enter. Get a positive number out, right? When x equals 4, when t equals 4, write that output function equals 1.65, which is positive, okay? Positive, okay? Now, right, we need to make sure v of t and a of t have the same sign, okay? So what's a of t? A of t is v prime of t, or x double prime of t, okay? And again, we don't have to do that by hand here because we get a calculator. We can just do it on our calculator, okay? Let's go back over to our calculator here. Okay, let's hit y equals, okay? So here's what we're going to do, okay? So y2 is my velocity function, right? Because it's the derivative of position, and the derivative of position is velocity, okay? So y2 is my velocity function, okay? The derivative of velocity, right, is our acceleration function, okay? So here's what I'm going to do. I want to take the derivative of y2. y2 is my velocity. I want to take the derivative of it and make it my y3. That y3 will be my acceleration function, okay? So go over here, hit math, right? Down arrow key, hit inderiv, okay? Sweeto. Okay, we're going to put an x there. We want to take the derivative with respect to x of our position function, of our velocity function, which is y2. So hit bars, hit the bars key. Let's go over to the right, hit enter. Let's go into y2, get that y2 pulled up. Okay, let's go over to the right. Okay, and you want x to equal x. Okay, now again, right, we only want, right, see these equal signs? We only want y3 to be highlighted. We only want to see our acceleration graph. So have your calculator graph it. Take a little while. It's all good. Alright, takes your calculator a little time to do this. Not instant. Oh my goodness. Dense. Ooh. Ooh. Slow down. Alright, down, okay. So now we need to plug 1, 2, and 4 into this acceleration function, okay? Right, so hit trace, hit 1, that means we plug 1 into our acceleration function graph here, hit enter, negative 0.7, negative, so for t equals 1, our acceleration is negative, for t equals 1, our acceleration is negative, okay, t equals 2, so trace 2, enter. Our acceleration, look, that's a negative number, negative 1.378407. That's a negative number. Okay, so for t equals 2, our acceleration function is negative. Okay, let's go back to here. And then for t equals 4, so trace 4, enter. Our acceleration is negative again. Oh my goodness. All right. Cool. So we got our chart all figured out. Done with the calculator, thank goodness. Okay. What were we saying our answer was? Our answer, right? They want all the t's from this list where the particles both to the right of the y-axis. Okay, so we already crossed off 3 and 5, so we're down to 1, 2, and 4. And is speeding up. Speeding up means v of t and a of t have the same sign. Okay. So let's look at 1, 2, and 4, our 3 remaining t values. Okay. So 1, right? We have the positive x of t. V of t and A of t are both negative, so they have the same sign, okay? So this is indeed, t equals 1 is an answer, okay? That's an answer, okay? T equals 2, right? Our x of t is positive. V of t and A of t are both negative, right? So that's going to be an answer, okay? 4, okay, x of t is positive, but V of t is positive while A of t is negative, right? So that's not going to be a solution, right? We're going to toss it into the fire. All right, so we just have 1 and 2, t equals 1 and t equals 2 are our answers. All right, and we're done. Okay, cool. You guys take care. Again, my apologies. I just wanted to do this problem more justice.